Look at the building, not the description, not the date on the plaque, the building itself. The stone joints are tighter than a human hair. The columns are mathematically proportioned to the inch. The load-bearing arches curve at angles that civil engineers still model on software when they want to understand how the structure hasn't moved in 200 years. We are told this was built by workers with hand tools, by a city government that had been operating for less than a decade, funded by modest municipal taxes, completed in under 3 years. And then you look at the building again, the detail work alone, the carved stone rosettes, the recessed panel moldings, the load distribution channels hidden inside the walls, would take a team of master craftsmen years just to plan. The quarrying, the transport, the foundations. The official timeline doesn't explain that. It doesn't even attempt to. The building still stands. The explanation quietly doesn't. The standard account of 19th century urban construction goes roughly like this. Cities across Europe and North America underwent a rapid transformation between approximately 1850 and 1900. Driven by industrialization, population growth, and expanding municipal governments, new civic buildings appeared at an accelerating pace. Courthouses, train stations, post offices, universities, hospitals, banks. The architectural style most associated with this period is broadly categorized as Neoclassical or Beaux-Arts, symmetrical facades, stone columns, decorative stonework, domed roofs, grand interior halls. The explanation for how these buildings were constructed points to a combination of factors: immigrant labor pools, newly available machine tools, the railroad network enabling stone transport, and architects trained in the European tradition. This explanation is presented as sufficient. Historians move past the construction question quickly toward the social and political purposes the building served. But the construction question doesn't go away on its own. When engineers and structural specialists study these buildings in detail, not historically, but technically, a pattern of anomalies emerges. Not in one building, or in one city, or in one country. The pattern appears across dozens of structures on multiple continents within the same compressed historical window. The official explanation accounts for the buildings existing. It does not account for how they were executed at that level of precision, at that scale, in that amount of time. Begin with something specific: stone jointing. In buildings constructed before the 20th century, the quality of stone jointing varies considerably depending on time period and available resources. Medieval castles show rough mortar joints, uneven surfaces, irregular coursing. Renaissance-era buildings show improvement, but still rely heavily on mortar as a gap-filling agent. Then something changes. In the class of buildings being examined here, primarily constructed between 1850 and 1880 according to official records, the stone joining in many structures reaches a precision level that requires explanation. Joints measured at less than 1 millimeter. Stone faces dressed to tolerances that require calibrated measurement equipment just to verify. Surfaces that appear to have been finished to a flatness standard that, in modern construction, requires power grinding tools. The question isn't whether this precision exists. It can be measured and photographed. The question is, what tools produced it? Hand chiseling and manual grinding can achieve high precision, but within physical limits. The human hand introduces variation. The time required to achieve sub-millimeter flatness across large stone surfaces using 19th century hand tools would be substantial. Not hours, not days, but weeks per surface. For surfaces that appear by the hundreds in some of these buildings, this raises a technical problem. The labor hours required to achieve documented precision levels across the scale of buildings in question does not reconcile cleanly with the recorded construction timelines. Historians don't typically address this calculation directly. The stonework is described as impressive. The method is not interrogated. When restoration engineers work on these buildings today, they consistently report the same observation. Matching the original stonework requires modern power tools and significant effort. Replicating it by hand to the same tolerance is either extremely slow or practically impossible at scale. That gap between the difficulty of replication today and the apparent ease of original production is not explained by the official account. It is, largely, not mentioned. There is one additional detail that tends to be overlooked in general discussions of this precision question. In several well-studied buildings, the precision is not uniform throughout the structure. The most exacting tolerances appear in the load-bearing elements, the columns, the foundation courses, the primary arch stones. Secondary decorative elements are executed to a slightly lower standard. Tertiary interior work, in spaces presumably less visible to the public. Lower still, this is not the pattern of a workforce learning on the job. It is the pattern of a workforce managing a limited resource, allocating the highest precision capacity to the most structurally critical applications, and distributing lesser capability to lesser tasks. That kind of allocation implies project management sophistication and a deliberate technical hierarchy that the official records do not describe. Precision is one part of the problem. Scale is another. Consider what it takes to quarry, transport, and place large structural stone blocks in the mid-19th century. Horse-drawn transport on unpaved or lightly paved roads, hand-operated cranes and block and tackle systems. A construction site organized by foremen with paper plans and verbal instruction. Now consider what is actually present in the buildings. Monolithic stone columns, sometimes 30 feet tall, cut from single pieces of granite. Entire facade walls of dressed limestone with perfectly aligned window openings to tolerances that a modern surveyor would be comfortable with. Interior hall floors of polished stone, cut and fitted so precisely that they appear to be single pieces at a distance. Moving a monolithic granite column weighing several tons in the mid-1800s, using only horse teams and rope and pulley systems, is not impossible. We have documented examples from antiquity, but it requires significant infrastructure, specialized knowledge, and substantial labor coordination. The records for many of these buildings do not show that infrastructure. Municipal archives, where they exist, describe relatively modest construction contracts, small labor forces, unremarkable budgets. The construction of a building that would require, by any modern engineering estimate, thousands of highly skilled labor hours per facade, is sometimes recorded with less paperwork than would accompany a modern residential renovation. This is not a claim that the records are falsified. It is an observation that the records are thin. Thin in a way that is difficult to reconcile with the physical evidence still standing. The question worth asking is, what kind of construction operation leaves behind almost no administrative trace? If the anomalies were confined to one region, there would be regional explanations available. A local stone type that machines more easily, a particular tradition of craftsmen concentrated in one area, a wealthy patron who funded better tools and longer timelines. But the pattern does not stay regional. The same architectural vocabulary, the same proportions, the same ornamental details, the same structural approaches, appears in buildings across North America, Western Europe, parts of South America, Russia, and Australia, all within roughly the same historical window. City halls in the American Midwest display the same facade grammar as railway stations in Central Europe. Courthouses in South America echo banking halls in St. Petersburg. The similarities are not superficial. They extend into structural decisions, interior proportioning, even the specific molding profiles used on cornices and baseboards. The accepted explanation for this is the Beaux-Arts tradition, architects trained in Paris, who then spread the style across the world through professional migration and published pattern books. That explanation is partially satisfying, but it only explains the design. It does not explain the execution. Design can travel in a book. Precision stonework cannot. The technical capability to execute these buildings at this standard would have required either a globally coordinated, skilled labor force or a set of tools and methods that were widely distributed and then largely disappeared from the record. What makes this harder to dismiss is the consistency of the disappearance. After approximately 1900, the construction of buildings at this standard of detail effectively stops. Not because architects stopped designing them. Beaux-Arts design continued well into the 20th century. The execution quality changes. Later buildings in the same style are visibly different upon close inspection. More mortar, less precision, ornamental details cast in plaster rather than cut in stone. Something that was possible before 1900 became either too expensive or no longer achievable afterward. The record doesn't explain what changed. There is one specific geographic dimension to this pattern that deserves closer attention. The buildings that display the most pronounced anomalies, the tightest jointing, the largest monolithic elements, the most technically ambitious ornamental work, are not uniformly distributed. They cluster. They appear with particular density in certain cities that, by the official historical record, were relatively young at the time of construction. Cities that had been formal municipal entities for 20 or 30 years were producing buildings of a technical standard that older, more established cities with longer construction traditions were not consistently matching. The distribution does not follow the expected pattern of accumulated local expertise. It follows a different pattern that the available documentation does not explain. This is where a specific hypothesis enters the conversation, one that exists largely outside mainstream academic history, but which has accumulated a following among people who study these architectural anomalies closely. The hypothesis involves a civilization or organizational entity referred to as Tartaria, sometimes called the Tartarian Empire. On historical maps, including maps produced by European cartographers as recently as the 18th century, the word Tartaria or Tartary appears as a geographic designation covering an enormous swath of Central Asia and, in some versions, extending across Siberia and into the American continent. Standard history treats Tartary as a vague geographic term for the steppe region beyond Persia and China, a label for an area, not a political or cultural entity. There is no mainstream academic framework that treats Tartaria as a unified civilization with its own architectural tradition. But the question being raised here is not purely political, it is architectural and technical. The specific claim, and it should be treated as a hypothesis, not a conclusion, is that the buildings now attributed to 19th century municipal construction may have predated that construction period, that what the historical record describes as newly built may, in at least some cases, have been inherited, repurposed, or reconstructed from an older structure. This is difficult to prove. It is also difficult to entirely dismiss. The evidence put forward includes the following. The physical condition of stonework in many of these buildings shows weathering patterns inconsistent with their recorded age. Stone that is said to be 150 years old shows erosion profiles that structural geologists sometimes associate with significantly longer exposure. Interior elements, carved details in protected spaces, stone floor surfaces, load-bearing components, sometimes show wear that seems disproportionate to the official timeline. None of this is conclusive. Weathering rates vary enormously based on stone type, climate, and maintenance history. The anomalies are suggestive, not definitive, but they point toward a question that the official account does not address. Has anyone systematically tested the actual age of the stone in these structures? In most cases, the answer is no. History survives through records, contracts, payroll ledgers, architectural drawings, correspondence, newspaper accounts, photographs. For important civic construction projects, these records are usually extensive. For this class of buildings, the record is uneven in ways that deserve attention. Some buildings have extensive documentation. Others, buildings of comparable scale and apparent complexity, have almost none. The construction of a major train station in a mid-sized American city in 1870 might be supported by a handful of newspaper notices and a single contract document. No detailed architectural drawings, no payroll records, no photographic documentation of the construction process, even though photography existed and was widely used for construction documentation in that era. Compare this to well-documented construction projects of the same period. The building of the Brooklyn Bridge, completed in 1883, is one of the most thoroughly documented engineering projects of the 19th century. Every phase of construction was photographed, described in engineering journals, and archived in multiple institutional collections. The buildings being examined here were often more architecturally complex than the Brooklyn Bridge in terms of stone craftsmanship and ornamental detail. Yet many of them exist in the historical record with less documentation than a minor road repair project of the same era. The explanation most often offered is that municipal archives were incomplete, that fires destroyed records, that local governments did not prioritize documentation. These are plausible explanations for some gaps. They are less plausible as an explanation for a systematic pattern of thin documentation across dozens of cities and multiple countries, all for a specific category of building, all within the same time window. There is something else worth noting about the documentation that does exist. When construction records are found, they frequently describe the finishing and fitting of a building rather than its foundational construction. Contracts for glazing windows, laying floors, installing doors, painting interiors, the envelope of the building. The stonework, the columns, the facades, the structural arches appears in the record after the fact, if at all. The documentation sequence is inverted from what you would expect. In a normal construction project, you document the structure first and the finishes later. In several of these buildings, the structure appears to have had no documentation phase at all. The evidence doesn't disappear. Only the explanation does. There is something worth observing about how these buildings are treated by the institutions that now own and preserve them. They are, almost universally, described as architectural achievements. They are listed on historic registers. They are photographed for tourism materials. They are praised in museum exhibits about civic history. The buildings are celebrated. What is not present in almost any institutional context is a technical account of how they were built. Tourism materials describe when a building was constructed and who commissioned it. They describe the architect's name and training. They do not describe how stone blocks of that weight were moved to that height, or how joints of that tolerance were achieved with the tools available, or how ornamental detail of that intricacy was produced at the rate required by the official timeline. Architectural history textbooks followed the same pattern. They analyze style, proportion, and cultural symbolism in considerable depth. The engineering and construction methods are either passed over briefly or described in generalities that don't engage with the specific technical questions the buildings raise. This is not necessarily suspicious on its own. Academic disciplines have boundaries. Architectural history is not construction engineering, but it does mean that the specific technical questions have no institutional home. No one is formally responsible for explaining how these buildings were actually built, and so the question persists, unanswered, while the buildings are praised for results that no one has fully accounted for. Preservation without understanding is a particular kind of silence. This point is worth examining directly because it tends to get softened in general accounts. When structural engineers, stonemasons, and construction specialists are asked to assess what it would take to build these structures today, not with 19th century methods but with modern equipment, the answers are consistently sobering. The column work alone in certain civic buildings would require modern quarrying equipment, precision cutting machinery, and specialized rigging. The facade stonework would require laser-guided cutting tools to replicate at the same tolerance. The interior ornamental stone, the carved capitals, the decorative friezes, the inlaid floor medallions would require either CNC milling or an extremely large and highly skilled team of traditional stone carvers working for an extended period. Cost estimates for replicating major buildings of this type from scratch, using modern methods, run into the hundreds of millions of dollars. Some architectural conservation specialists describe certain buildings as essentially irreplaceable, not because we lack the design knowledge, but because we lack either the economic justification or the technical workforce to execute at that standard. This is the part of the conversation that tends to stop, because if modern technology, with all its advantages, cannot easily replicate these buildings, then the question of how they were produced in the first place, without that technology, in a compressed timeline, with an inadequately documented labor force, becomes considerably more difficult to dismiss. The mainstream answer is that skilled craftsmen of the 19th century were simply better at traditional stonework than modern workers. Because traditional skills atrophied after the industrial transition, there is truth in this. Traditional stonemasonry is a diminishing profession. But this answer shifts the problem rather than resolving it. It requires us to accept that the 19th century had a concentration of highly skilled stone craftsmen, distributed globally, capable of executing at an extraordinary standard, who left almost no training tradition, almost no written technical instruction, and almost no direct descendants in the craft. Skills don't disappear that cleanly. Knowledge systems usually leave traces: apprenticeship records, guild documents, technical manuals, teaching traditions. The technical knowledge required to produce these buildings at this level should have left a substantial record. That record is difficult to find. What is particularly notable is the absence of failure. In any genuine period of intense craft production, the historical record includes not just the successes but the abandoned projects, the collapses, the reconstructions, the public disputes over quality. A labor force pushing the boundaries of its technical capability leaves evidence of that struggle in the form of errors and corrections. For this class of building, even the evidence of difficulty is largely missing. The buildings appear in the record as though they were completed without significant incident, to an extraordinary standard, on schedule. That absence of difficulty is itself unusual enough to raise a question. There is a specific pattern in the history of technology that archaeologists and historians recognize as significant: capability that appears fully formed without a visible developmental sequence, and then disappears without an obvious cause. The typical model of technological development is incremental. Early attempts are crude, refinements accumulate over generations. A mature capability reflects decades or centuries of visible improvement in the archaeological or historical record. The buildings under examination do not follow this pattern cleanly. The construction quality seen in the 1850 to 1880 window does not have a clear local developmental precursor in many of the cities where these buildings appear. A city that has, by official record, spent the previous 50 years building modest wooden commercial structures and simple brick residences, suddenly produces a massive granite civic hall with precision stonework and proportional sophistication that would be impressive by any standard. The jump is abrupt. The standard explanation, access to European-trained architects and imported labor, is present in some cases and absent in others. In cases where it is present, it accounts for the design. It still does not fully account for the execution. Then, by approximately 1910, the peak is passed. Buildings of this type are still designed and labeled as neoclassical, but the standard of stonework is measurably different. Facades are more often brick with stone facing rather than solid stone. Ornamental detail is more often cast in concrete or plaster rather than hand-cut in stone. The technical ambition contracts. It contracts globally, across the same time window. The transition from peak capability to reduced capability happens too consistently across too many locations to be explained by purely local economic decisions. Something changed at a broader level. What changed is not documented in a way that fully accounts for the shift. There is an alternative framework for understanding this pattern, one that does not require accepting Tartaria as a proven historical entity, but which takes the architectural evidence seriously on its own terms. It is possible that the buildings described as constructed in the mid-19th century were not constructed in the mid-19th century. It is possible that some portion of them were inherited structures, buildings that predated their official construction date by decades or longer, and were reclassified, renovated, or officially founded at the point when their new administrative purpose was established. This is not an unprecedented concept in architectural history. The reuse and reclassification of existing structures is well documented. Churches built on the foundations of older temples, civic buildings constructed inside or around earlier shells, dates of founding that refer to political or administrative events rather than actual construction. What would this mean for the Tartaria hypothesis? It would suggest that an architectural tradition of high technical capability existed prior to the official historical window, that the buildings we attribute to 19th century construction effort may in fact represent the visible remnant of an earlier, poorly documented civilization with sophisticated building knowledge. It would explain the global consistency. The style and technique are consistent because they originate from a single prior tradition, not because they were independently developed in parallel across multiple continents. It would explain the thin documentation. The buildings were not constructed in the period they are dated to, and so the expected construction records do not exist because the construction happened earlier. It would explain the sudden disappearance of technical capability. The tradition that produced the buildings was not actively practiced in the 19th century. It was inherited, and once the inherited stock was exhausted, or the knowledge of how it was done was lost, replication became impossible. This is a hypothesis. It is not a proven account. Each element of it is contested, but it is also, at present, the only framework that attempts to address all of the anomalies simultaneously. The official account addresses none of them directly. At this point, it is worth being precise about what has and has not been established. What the evidence suggests, buildings exist that display technical characteristics difficult to reconcile with their official construction dates, available tools, and documented labor forces. The same pattern appears across multiple continents within a specific time window. The technical knowledge required to produce these buildings does not have a clear developmental record and did not survive the period in which the buildings were supposedly built. Modern replication is technically demanding and economically prohibitive. What has not been established, that Tartaria was a defined empire, that a historical reset deliberately obscured prior civilizations, that the official historical timeline is fabricated, or that any specific institution has knowingly concealed information. The gap between those two positions is where the actual investigation should occur. What would serious investigation look like? It would involve systematic material testing, radiometric and other dating methods applied to the actual stone and contested buildings. It would involve a technical engineering analysis of construction requirements versus documented resources. It would involve a comparative architectural study that examined execution quality, not just design vocabulary, across the relevant period and geography. That investigation, as a formal academic or institutional project, has not been conducted. There is a reason worth considering for why it has not. The buildings in question are not in obscure locations. They are functioning courthouses, active train stations, occupied government offices. They are used daily. They are maintained by institutional budgets. The people responsible for them are not historians or engineers. They are administrators, The question of how a building was originally constructed is not a question that any current occupant is required to answer, and so it is not asked. Not formally, not with resources behind it. The physical evidence accumulates maintenance cycles and tourism visits while the technical question sits undisturbed. That is not a conspiracy. It is something more ordinary, institutional indifference to questions that fall between jurisdictions. No department owns the question, so no department answers it. The buildings sit, preserved and praised, with their technical questions unasked by the institutions that house them. There is a particular category of anomaly that is harder to dismiss than a factual error. A factual error can be corrected. A gap in the record can be filled. But a structural inconsistency, one where the physical evidence and the official explanation face in different directions, persists as long as both the evidence and the explanation exist. These buildings are not going anywhere. They are maintained, photographed, and officially honored. The stonework can be measured today. The jointing can be analyzed. The weathering patterns can be studied. The construction timelines are on record. What is not present is a serious technical account of how the one produced the other. The question is not whether a prior civilization definitively existed, or whether Tartaria was a real empire, or whether history was deliberately rewritten. Those are large claims that require large evidence. The question, kept to what is actually measurable, is simpler. Did the documented tools, documented timelines, and documented labor forces of the mid-19th century produce the buildings that carry those dates? If the answer is yes, the technical explanation should be straightforward to produce. It has not been produced. The buildings remain. The method that made them does not.